can groundwater pumping trigger a sinkhole collapse? Imagine walking down a street, and suddenly, the ground beneath your feet starts to crack and sink. That's what can happen when groundwater pumping causes a sinkhole to form. Sinkholes are natural depressions or holes in the ground, often in areas with limestone or other soluble rocks. These rocks slowly dissolve over time because of slightly acidic groundwater, creating underground cavities. Usually, the pressure from the water keeps the roof of these cavities supported. But when too much groundwater is pumped out, the water level drops and the support weakens. Without the water pushing against the cavity roof, it can suddenly collapse. This collapse causes the surface to give way, forming a sinkhole. The process begins with groundwater slowly dissolving limestone or similar rocks underground. As the rock dissolves, it leaves behind empty spaces or cavities. When groundwater levels are high, the water acts like a cushion, holding up the roof of these cavities. But if groundwater is pumped out excessively, the water table drops. This reduces the buoyant support that water provides, making the roof of the cavity unstable. When the support is gone, the roof can fall in, and sediments above it collapse into the cavity. This sudden collapse creates a sinkhole at the surface. This is especially common in areas like Florida and parts of Texas, where a lot of groundwater is used for farming and cities. Pumping can cause the water table to fluctuate seasonally, which weakens underground layers over time. Clay layers and other materials expand and contract with changing water levels, adding stress to the underground structures. Repeated changes can make the ground more prone to collapsing. Pumping near natural fractures or joints in the bedrock makes the risk even higher. These fractures act like weak spots where the ground can break more easily. When groundwater is extracted near these zones, it increases the chance of a collapse. Sinkholes caused by groundwater pumping can happen quickly and without warning. They can damage roads, buildings, and even cause injuries or fatalities. To prevent this, monitoring groundwater levels is very important. Managing how much water is pumped and avoiding excessive extraction helps keep the ground stable. Before construction projects, geologists often do surveys to identify weak spots. Some areas may need special engineering solutions to stabilize the ground. In short, if too much groundwater is pumped out, it can cause underground cavities to lose support and suddenly collapse. This creates sinkholes that can be dangerous for people and property. Proper management and careful planning are key to avoiding these geological hazards.